Alright, so now we're going to start part 2 of chapter 5, which deals with the global pressure belts. So there are 4 of these global pressure belts, which are essentially latitudinal zones at certain latitudes around the Earth that have specific temperature and pressure characteristics. Now, it's important to keep in mind as we go through these that these conditions are not universal at all of these latitudes. In fact, where we live in the Gulf Coast of the United States is a pretty significant exception to the general trend where we are. I'll explain that as we go over it. So our first global pressure belt that you need to know is what we've already talked about in the previous unit, which is the ITCZ, the Intertropical Convergence Zone. So this pressure belt follows the subsolar point as it travels around the Earth over the course of a year, bouncing between the two tropics. The ITCZ will always be in and around the latitude of the subsolar point. Not always right on it. It'll be higher or lower in certain points depending on where land is and other things. But it'll always be nearby. And it's very warm and very rainy. A lot of violent thunderstorms. Because it's very hot, it creates a very low pressure zone, so it causes a lot of convergence from higher pressure air on both sides to that spot, and it leads to a lot of storms, such as the monsoons in India and also the summer thunderstorms that we get here in Louisiana. So our second pressure belt that you'll need to know is what is called the subtropical high. That's about at the latitude where we are. It's centered around 30 degrees latitude, both north and south. We're right about 31 degrees north here in Baton Rouge. New Orleans is almost exactly 30 degrees. So this is right at the latitude we are. In most parts of the world, the subtropical high is relatively warm, but also dry. In many parts of the world, this produces a very dry, sometimes even a desert climate. But we're kind of an oddball exception to that just because we're so close to the Gulf of Mexico, which has very warm water, and this causes us to get lots of annual precipitation, especially in the summer. So we get way more precipitation than most places at our latitude around the world do. So we're kind of an oddball exception. But in most parts of the world, in this subtropical high zone at 30 degrees north and south, it's dry. It's warm, but it's also quite dry. We're at the same latitude as Cairo, Egypt, which is a desert. We're not far from the Gobi Desert in Asia. Most of the United States and Mexico to the west of us is desert or near desert at the same latitude. So don't get confused thinking of Louisiana's climate. We're kind of the oddball exception to what most of the Earth is like at our same latitude. That's the subtropical high pressure belt. And it makes sense why a high pressure belt would be dry, right? Because in a low pressure system, you have convergence. The air is warm, it'll converge and then rise, which will cause condensation and precipitation at the areas near where that's happening, like the ITCZ. With a high pressure zone, you have the opposite. You have drier air that is coming down and then diverging outward. It doesn't have the opportunity to have any rain at those spots. So that's why most of the world, you have a very dry or even a desert climate in that subtropical high zone. We're the exception because we have a very different climate. We're right near the Gulf of Mexico, but in most parts of the world, it's very dry because of that diverging effect that the air does. So the third pressure belt that you'll need to know is called the subpolar low. This is a low pressure belt that's found about 60 degrees both north and south. So very, very cold, and it's very, very wet air relative to the air around it. And what's interesting is that higher up in the atmosphere, where the subtropical high air meets the subpolar low, we have a very fast, powerful jet stream here in North America, and that's what airline pilots use to fly from the United States to Europe. They kind of follow that jet stream, and it saves them a lot of jet fuel because it's a very, very powerful wind. They don't even have to use any jet fuel or very little while the plane is in that a polar jet stream. So that's kind of what's special about this area. So the subpolar low is cool and wet. So it's cool just because of how high up we are in terms of latitude, but it's wet because of that convergence effect. So it's a low pressure zone, so that causes the higher pressure air around it to converge, and when it converges, it lifts, and that creates precipitation in the areas nearby that pressure belt. So that's why the northwestern part of our country gets very rainy, even though it's quite cold. That part of the US and Canada gets a lot more precipitation than it would otherwise because of that low pressure zone effect. And finally, our fourth and final pressure belt is called the polar high. It's very cold and very dry air because, again, it's so cold at the poles that there's no liquid water at the surface, or very little for there to even be cloud formation. It's so cold that that's not even possible. So the polar high pressure belt is very cold and very dry. It's, of course, found at the poles, and this is where polar deserts are found. So a desert is any part of the earth that gets 10 centimeters of rain or less per year. A lot of people think deserts are only in hot, sandy areas, but the poles are also deserts too, because they get such little precipitation. And this polar high pressure belt, it keeps the areas that it affects very dry because there's no moisture where it starts, and because it's high pressure air going in one direction, it's just going to bully the lower pressure air out of the way. So it keeps most of the climate near where this pressure belt is very dry. Only on occasion will those areas get precipitation. That's why they stay a sort of tundra or a frozen wasteland desert area, because of these effects. So we've covered the four pressure belts. Now we're going to talk about the global surface wind patterns. So these are the winds that occur near the surface of the earth, not high up in the atmosphere and not in the ocean. These are the ones that affect us right at the surface. And this is the diagram that we had you guys draw in class with the globe and all of the different types of winds. That's what we're about to talk about right here. There's a good diagram in your textbook. All right, so our first global surface wind pattern is called the trade winds. These are easterly surface winds, so they flow from the east westward. Easterly surface winds found between the ITCZ and the subtropical high. So between the equator and 30 degrees both north and south. So the tropics and subtropics are where you're going to find the trade winds. And they're called the trade winds is because when the Europeans were colonizing the Americas, these are the winds that they used to get there, because they flowed from the east where Europe and Africa were west to the Americas. That's why we call them the trade winds. The trade winds are the most geographically extensive and consistent winds on the Earth's surface. They're very reliable. They occur almost every day. Sometimes they're more powerful than other times, depending on where the ITCZ is. But in our part of the world, they tend to be pretty powerful. Our next type of surface wind are the westerlies. So the westerlies are surface winds that come from the west and are found in both hemispheres between the subpolar low and the subtropical high. So between 30 and 60 degrees latitude, both north and south. That's where you find the westerly winds. And the westerlies are the most prevalent wind systems here in the United States, because almost all of our country is found between about 50 degrees north and 30 degrees north. So that's exactly where these surface winds are found. So that's what affects our climate a lot, and also parts of Europe and Asia as well. The westerlies assist with sailing from the United States to Europe, whereas with the trade winds, it was the opposite. They assisted with trading from Europe and Africa to Central America. And our final type of surface winds are the polar easterlies. So these are cold, very dry winds that originate near both poles, and they flow south and east. The polar easterlies, so they're very cold and very dry. And the polar easterlies are deflected to the right by that Coriolis effect that we talked about earlier. So the poles are a very high pressure zone, and as the Earth spins, what wind there is will get deflected off to the right. That wraps up the three types of surface winds that we're covering in this class. It's also important to remember how temperature over land affects our climate patterns. So over land, the seasonal heating and cooling creates thermal low pressure regions in the summer when it's hot, and thermal high pressure regions in winter. And we call these semi-permanent pressure systems because they're usually pretty reliable on an annual basis unless something weird happens with the climate, like an El Nino event that we'll talk about later. So in our case in Louisiana, in the summer, we're close to the ITCZ and we get a lot of direct heat. So our land in the Gulf Coast gets really hot, and it creates a sort of semi-permanent low pressure zone here during the summer. And that's why we get so much rain during the summer, because the higher pressure air over the Gulf is bringing that warm, moist air over land, and then we get the precipitation from that. The opposite of that would be in the winter in the northern part of our country, over Canada and most of the Great Plains. There's a permanent high pressure system that just spits out a bunch of high pressure, very cold air, and it tends to come south because that's where the air is at a much lower pressure, so that's where the pressure gradient is going to drag it. So that's why we get those periodic cold fronts here, where that really cold air from Canada comes all the way across our country, and eventually it pushes the air out of the way here, and we get really cold all of a sudden for a couple of days. That's what happened. It's that semi-permanent climate pattern that we get over land. So we'll briefly discuss what a sea breeze and a land breeze is again. So a sea breeze is a local onshore breeze caused by the heating and cooling differences between the water and the land. So what the land is going to heat up much faster than the water, right? Because of the specific heat factor we talked about in Unit 1. So the land heats up faster. That creates a pressure gradient where the land has a lower pressure than the water. So the water is going to, the air over the water, which is higher pressure, is going to move towards land. And it might bring moisture with it. It might not. But that's what a sea breeze is. They tend to be very calm, slow winds. And they're onshore winds because they're blowing on the shore from the ocean onto the land. Remember, the onshore and offshore breezes are the one type of wind pattern where we don't name it for the prevailing direction. In this case, we name it for where the breeze is going rather than the direction where it came from. And the opposite of that would be a land breeze, also called an offshore breeze. It's again caused by the heating difference. That's when the ocean is warmer than the land, which happens at night. So at night, as the surface of the earth cools down, it creates a small high pressure zone over the land, and that creates a very calm, gentle wind from the land offshore towards the sea. So to recap, a sea breeze and an onshore breeze are the same thing, two different ways to describe the same thing. That's when the breeze is coming from the sea onto land. And then the other side is a land breeze and an offshore breeze are the same thing. That's when the wind is coming from the land offshore into the water. So now we'll briefly talk about monsoons, which you should know for your test. So the most famous example of a monsoon in our world happens in South Asia, the area that composes roughly India, Pakistan, Bangladesh, countries around there. So a monsoon is a seasonal reversal of winds characterized by onshore airflow during the summer and offshore airflow in the winter. And that makes sense, right? Because in the summer, the land heats up. It has lower pressure than the air around it in the ocean. So that causes moist air that was over the water to come inland because of that pressure gradient. So during the summer, India and Pakistan and Bangladesh get a tremendous amount of rain, and it sometimes leads to horrible flooding that affects millions of people. And the opposite happens with this monsoon in the winter. So in the winter, the land is much colder, especially around the Himalayas, than the Indian Ocean. So it creates an almost drought effect where the high pressure air over the Himalayas flows offshore across India, and it blocks them from getting the moisture they would otherwise get. So it's a very strong offshore breeze that moves dry air across the subcontinent. So because of this monsoon effect, India has very, very wet, hot summers that cause lots of flooding, and the winters there are quite dry because they have an extreme example of this monsoon effect. Just because of the presence of the mountains and because of the shape of India, it, it's almost surrounded by water in a lot of areas. It's a peninsula, so it is a very extreme effect of this monsoon pattern. So next we'll talk about the difference between a valley breeze and a mountain breeze. So now we're back to naming winds from the prevailing direction from whence they came, not like the onshore and offshore thing. We're back to naming them from the prevailing direction. So a valley breeze is a local upslope breeze that starts in the valley and flows up into the mountains. And it's caused by the heating and cooling differences in the mountain areas. So let's imagine on a hot day in the valley,